So when I try to explain the atomic spectrum here, I explained that when the electron was excited, they will jump to another orbit, and this orbit is discrete, not continuously. So the energy of the electron is also discrete. So I only describe that, but I did not provide you explanation why the orbit should be discrete. So the first one proposed a reasonable argument based on the quantum hypothesis by the Planck to explain the atomic spectrum is the Bohr. So Bohr proposed the first realistic model, but eventually it is not true, but they are close to true picture. He said that this picture is very similar to the nucleus is the center, and the electron is orbiting around the nucleus. However, when the electron is orbiting around the nucleus, they have a bunch of electrons. So how did you describe the position or the orbit of the electrons? They say that based on the quantum hypothesis proposed by the Planck, the orbit should be quantized, which means that the electron is only allowed to orbit around the nucleus at a certain distance, and each orbit has their own energy. So this is basically a continuation of the Planck assumptions. So based on that, because the electron have a negative charge and the nucleus have a positive charge, so from the chapter 4 we have learned that now the electron will have the electropotential energy. So if the extra energy is provided to the electrons, in this case it is a photon, so the photon will come in and interact with the electrons, and we just learned that the energy carried by the photon is proportional to the frequency of the light. So now all the energy will be given to the electrons, and now the electron have more energy than the energy required to stay in that orbit. So now the potential energy of the electron is higher, so they will jump to a higher potential energy orbit. So this is the excitation to this one. And later on, when the electron jumping back to the lower potential energy orbit, they will emit the energy between the difference of these two energy levels. So therefore, when the electrons in any energy level, they drops too closer to the nucleus, they will emit a photon. And the energy of the photon depends on the difference of these two energy orbits. And now Bohr say that there are a number of the discrete energy levels within the atoms. So for example, this is one of them, this is second one of them. But if this is the first one, this is the second one, there's nothing in between. There's no energy level allowed. So it is a discrete number of orbits, and each of the orbit can be described by a quantum number n. So now the quantum effect start to play a role here. So you can give a number for each of the orbit with a quantum number n, and n is integers from 1, 2, 3, 4, 5, 6. And n equal to 1 is the lowest energy of the orbit. So it is most close to the nucleus. So apparently, you can using the knowledge you learned in the chapter 8 and 9 to think about it. Because the nucleus carry the positive charge, electron carry the negative charge, so they try to attract to each other. So if you try to bring the electron further away from the nucleus, which means you have to do the work. And what do you mean you have to do the work? It is the photon have to provide the energy, and the energy will excite the electrons, and the electron will start to jump. So the n equal to 1 is the lowest energy of the orbit, and it is also geometrically most close to the nucleus. And simultaneously, because the orbit is discrete, so when the energy drop to any levels below the original one, they will emit a photon with a specific number of energy. So therefore, the spectrum produced should be also discrete. So it depends on whether the light is jumped from the n equal to 4 to n equal to 1, or n equal to 4 to n equal to 2. If you jump between different energy levels, the light produced will be different, and each of them they have their unique frequency. So there's the reason why eventually each of the atoms will produce a spectrum, discrete lines of the spectrums, and each of them has different kind of the spectrum because the energy orbit for each atom is different. So some of them have a narrow band of the energy orbit, some of them have a border band of the energy spectrum at the orbit. So this is a very important concept. So the concept proposed by the Planck and by Bohr model here is the foundation of the modern physics. Okay, so now let's have our another question quiz. So which one is the possible quantum number? So based on our discussion, the only answer is C. The quantum number is the integers. It could not be 0.1, 0.2, or 2.5. As long as it is not an integer, it cannot be a quantum number. So the Bohr's model is actually very successful at the very beginning. And one of the reasons people start to accept that, even though eventually it is not realistic, is that originally they can explain why the atoms do not collapse. So have you thought about that if the electron is negative charge, nucleus is a positive charge? Based on the knowledge we learn from the electromagnetism, the electron will simply be attracted to the atoms, and they will simply collapse. That's what we mean. The atoms will collapse. So you cannot form an electron orbiting around the nucleus. So the answers is, based on the Bohr's model, the electron can lose only specific amount of energy. What does that mean? So you cannot arbitrarily give them the energy, then they will start to jump. You have to provide exactly right amount of energy. So which means even though the electron was attracted to the nucleus, but in order for the electron to jump from n equal to 5 to 6 or from n equal to 5 to 1, you have to provide the exactly amount of energy, or the electron have to release the exact amount of energy in order to jump to n equal to 1 or even lower 1. But in fact, this is very hard, and basically intrinsically it is not common. So most of the time the structure of the atom will be stable. Most of the electron will just orbiting around the nucleus, unless with a special condition that the appropriate energy was provided, then they will jump to the lower or higher energy. And the n equal to 1 is the so-called lowest energy orbit, so sometimes people will call it is a ground state. So what do we mean by the ground state? It means that there's no way the electron can jump more close to the nucleus than this one. So this is a closed layer of the electron can orbiting around the nucleus. So this is also the other way to understand this. The electron cannot even lose any more energy. This is the lowest point. You cannot even say, I want to remove another certain amount of energy. Can you continuously approaching to the center of the nucleus? The answer is no. So based on these two facts, the energy for each orbit is fixed, so you have to provide the specific amount of energy for the electron to move. And also, the existence of the ground state means that you cannot even reach closer distance to the nucleus than the ground state. So based on these two, the structure of atoms is stable. They will not easily collapse. So this is the so-called planetary model of the atoms. So all the photons was emitted by the atoms as the electrons move from higher to a lower energy level, as I just mentioned. And the energy of the emitted photon is equivalent to the difference of the energy between the two energy levels, which is specific. So this one basically summarizes what we have said so far, using the Bohr's model to explain the spectrums. So, because the duality I just mentioned, so electron originally we thought it is a particles, but intrinsically everything carries their own wave property, and apparently the electron is a very light particles. So the wavelength produced by the electron is not very long. So the wave properties of the electron is important. So that's the reason quantum physics is particularly useful at the level of the atomic structures. So because the wave nature also carried by the electrons, so this permit energy level the electron is orbiting, intrinsically it is the standing electron wave. Because if it is a wave, ideally they have a chance to produce a standing wave. And this is the thing we have studied in the chapter 10, 11. So you can basically treat the fixed energy level here as a standing wave, of the electron wave. And this is a very crucial way to help us to understand why the discrete energy symmetry is allowed. Because in a standing wave, do you remember that? We also have the discrete mode. The mode is from n equal to 1, 2, 3, 4, 5 mode. We don't have 1.1, 1.2 mode. Agree? So if you don't remember about the standing wave, please go back and check it. So because of the wave natures, the energy is actually quantized to a specific number. So for example, n equal to 1 means one single wavelength, and n equal to 2 means the two wavelength mode of the standing wave. So pictorially, you can treat this is the case. Did you see that depending on the vibration of the wavelengths, this is the ground state, and they will form a more and more complicated standing wave. But try to think about it, they are just the wave produced by the electrons. Okay, so therefore, only the integer number of the standing wave can occur. Explain why the energy for each orbit is fixed. It is quantized. There are only specific number of the energy could be allowed. So intrinsically, you can treat that the motion of the electron orbiting around the nucleus is something like a wave oscillating back and forth. Okay. So finally, we can use that to help us to understand the periodical table. So intrinsically, the structure of the atoms can be understood in terms of the shell models. So shell model means that this is the distinct and the quantized energy orbit for the electron to orbit. So the electron is only allowed to stay in the, for example, n equal to 1, n equal to 2 orbits. And did you see the number here? The shell model tells us that the electron is there are only 2 electrons allowed to stay in the first shell, and there are 8 electrons are allowed to stay in the second shells. So the number means that the maximum number of the electrons are allowed to stay there. So the last slide today is that now we can use the shell model to understand, for example, the first 3 the periods in the periodical table. So for the hydrogen, you have 1 proton, so 1 electron is orbiting. So this 1 electron is the first orbit here. Now the first orbit can accommodate 2 electrons, yeah? So now the second electron comes in. But if you have the third electrons, then the first orbit is no longer allowed. You have to jump to the second orbit. So the second orbit can have 8 electrons. So you can see now you have 1, 2, 3, 4, 5, 6, 7, 8. And when the 8 electrons are all filled in the second layer, you have to go to the third layer. So did you notice that the helium, neon, argon are the so-called noble gas? Why the noble gas is lazy to interact with each other? It is because the electrons fall in the outer layer of the orbit. So there are no more space for the electron to come in and out. So that is the reason that you can explain the noble gas, the property of that, using the concept of the shell models. So this is a very important concept using the quantum physics to explain the periodical table.